So today we have x to the power of 2 all over 49 equals to 49 all over x to the power of 2. So we're going to solve together. Let's take solution. X to the power of 2 over 49 equals to 49 over x to the power of 2. So what we do, we're going to cross multiply so that the next line becomes x to the power of 2 times x to the power of 2 equals to 49 times 49. But 49 can be represented as 7 to the power of 2 in an index form. So the next line becomes x to the power of 2 times x to the power of 2 equals to 7 to the power of 2 times 7 to the power of 2. Again, a to the power of n times a to the power of m is equals to a to the power of n plus m. So we're going to apply it here so that the next line becomes x to the power of 2 plus 2 is equals to 7 to the power of 2 also plus 2. And we are fine. And this can be written as x to the power of 4 is equals to 7 to the power of 4. If we take 7 to the power of 4 to the left hand side, it becomes x to the power of 4 minus 7 to the power of 4 equal to 0. And here, from exponent, where we have a to the power of n to the power of m can be written as a to the power of n times n. In the same vein, where we have a to the power of 2 times 2, this also equals to a to the power of 2 times 2. This is equals to a to the power of 4. So we can apply this here so that the next line becomes x to the power of 2 to the power of 2. 2 times 2 is 4 minus 7 to the power of 2 also to the power of 2. 2 times 2 is 4 equals to 0. And this is a case of difference of two squares. And from algebra, we have a to the power of 2 minus b to the power of 2, which is represented as a plus b and a minus b. So this is in the form of this, where x is equals to a, x squared is equals to a, and 7 to the power of 2 is equals to b. So to implement this, we are going to write as x to the power of 2 plus 7 to the power of 2 for this times x to the power of 2 minus 7 to the power of 2 equals to 0. So here we're having two cases, and case 1 is x squared plus 7 to the power of 2 equal to 0, and case 2 is x squared minus 7 to the power of 2 equal to 0. For case 1 is a case of sums of two squares, which is represented as a to the power of 2 plus b to the power of 2, and is equivalent to a plus bi times a minus bi. S equals to a, and 7 is b. So there we have x plus 7i times s minus 7i equals to 0. Again, we're having two cases where we have x plus 7i equal to 0, or x minus 7i equals to 0. From here, x is equals to minus 7i. That's x1, and x2 is equals to 7i. And we're fine. And from case 2, again, this is a case of difference of two squared, where we have a to the power of 2 minus b to the power of 2, and it's represented as a plus b, a minus b. And here we have x plus 7 times x minus 7 equals to 0. so that x will be equals to minus 7 and x will be equals to 7. So the values of s1 is equals to minus 7i, and x2 is equals to 7i. Here s3 is minus 7 and s4 is equal to 7. These are the values of s. We're going to verify just at least two to see if this value can satisfy the original equation. So to do this, from original equation, s to the power of 2 over 49 is equals to 49 over x to the power of 2. So for s equals to minus 7i, s equals to minus 7i, which is x1, we have our equation as minus 7i to the power of 2 over 49 equals to 49 over minus 7i to the power of 2. Here, minus 7 to the power of 2 is 49. I raised to the power of 2 over 49 equals to 49 over 49 times I raised to the power of 2. Here, 49 can cancel out. What is left is I to the power of 2 over 1 equals to 1 over I to the power of 2. And I to the power of 2 is minus 1. So minus 1 over 1 equals to 1 over minus 1. Eventually, this gives us minus 1 is equals to minus 1. So it's true for the value of s equals to minus 7i. And again, for x equals to 7, our original equation s to the power of 2 over 49 will be equals to 49 over x to the power of 2. So here we have 7 to the power of 2 over 49 equals to 49 over 7 to the power of 2. And 7 to the power of 2 is 49 over 49 is equals to 49 all over 49. And this is equals to 1 over 1. When it cancels out, also it's true that the value of s equals to 7 satisfy the original equation. You can try this and this on your own. Thank you for staying tuned to this time. Please help us to promote this channel, subscribe, like, and share. Bye-bye.